Hello everyone and welcome back. This is my third video for CTP2. This will be my final video for the thesis and I will be concluding my project along with a brief overview of the project. In this slide I will be giving an overview of my thesis. I started off the project by providing the overall design of the automated greenhouse monitoring system in video 1. Then, in video 2, I showcased my completed temperature sensor along with the simulation. In video 3, I presented the soil moisture sensor and the humidity sensor with the completed working simulation. In the fourth video, I portrayed the light intensity sensor part of the project and also showcased the working simulation for this part. In the fifth video, I finally added my last sensor, the carbon dioxide sensor. Although this sensor was not planned in the original proposed approach, it was later decided to be added in due to the insights provided by the project supervisor. This was followed by the sixth and the final video, which is the one you're watching right now. The screenshot of the circuit shown on the screen is the final simulation of the automated greenhouse monitoring system. All the components have been fit in together to make the system work as one. Instead of working individually like it did earlier, the final components used in this simulation are transmitter, soil moisture sensor, serial monitor, humidity sensor, light intensity sensor, temperature sensor, carbon dioxide sensor, covers, artificial lights, water pump, spray, heater, fan, CO2 valve, and receiver. In this slide, I will be showing the working of the final simulation. As stated earlier, all the sensors were assembled together with Arduino Mega and the circuit worked as expected. Initially, Arduino Uno was used to simulate each of the sensors, but in the final simulation, Arduino Mega is used since it has more input and output pins. Arduino Uno could have been used, but the analog pins have to be converted to digital pins. Therefore, to reduce the complexity, Arduino Mega has been used. It can be seen that this circuit is wireless. This is because Proteus has the capability of removing wires to make the circuit more professional and make a viewer understand the pin connections. When I made the circuit with the wires, it was very confusing to figure out which pin was connected to which port. The left side of the circuit shows the sensors along with the receiver unit, and the right side shows the transmitter unit with the necessary actuators that control and maintain this greenhouse. It can be seen that the light intensity defined levels are controlled by the artificial lights as the sunlight level received by the plants increases or decreases. The covers are in open and closed positions when the temperature and carbon dioxide levels exceed the limits. This is done to reduce the abnormality of the operating conditions. The temperature level is controlled by heater and fan. When the temperature exceeds the limit, the heater turns on, and when it goes below the limit, the fan turns on. These two work irrespective of each other and control the temperature level suited to plants. The soil moisture level is controlled by water pump. When the water level is low, the analog voltage will be low in soil. The analog voltage will keep increasing as the conductivity between the electrodes in the soil changes. Hence, I have used a variable resistor which works with the same functionality as a soil moisture sensor. The major reason why using a variable resistor as soil moisture sensor is possible is because the probes in the soil moisture sensor are variable resistors in reality. The inputs obtained from the analog sensor are captured by Arduino. When the sensor does not sense moisture in the soil, the water pump is turned on until it reaches the required level. The carbon dioxide level is controlled by CO2 valves. The sensor is coded according to the changes in voltage level, which in turn changes the concentration. The level of concentration controls the CO2 valve. When the concentration is above the defined level, the carbon dioxide valve closes and the ventilation flaps open. When the concentration is below the defined level, the valve of the compressed carbon dioxide opens and carbon dioxide is supplied in the greenhouse, and the ventilation windows close. The humidity level is controlled by water sprays. If the humidity of the environment is below the defined levels, sprays are automatically turned on, and if the humidity level exceeds the defined level, sprays are automatically turned off. Throughout this whole procedure, continuous alert of live data is sent to the owner or the operator, and it contains the data of all parameters. This is done using radio frequency technology, where a receiver is used to obtain the data from the sensors, which is then sent to the transmitter, which is located where the operator is located. The operator will receive the data showcasting status of the level of all the elements in the greenhouse. The codes for each sensor were put together in Arduino IDE and the hex file was transferred to Proteus. This is the code for the final simulation. Now, coming back to the presentation, future work. First, the sensor data can be acquired and stored in a database, which can serve as effective means of storage of critical information, which can be looked upon later. It can also be used for making important decisions later and conclude on the effective working of the system. Next, more sensors can be added into the system to make the greenhouse more efficient in working. Due to time restrictions, I only added the most significant sensors required for the fundamental working of the greenhouse. Other sensors which can be added are pH monitoring sensor, leaf wetness detection sensor, and fertilizer measuring sensor. By implementing solar technology on the nodes inside the greenhouse, the consumption of energy will decrease and the system will become more cost effective. Fourth, GSM and SMS can also be integrated into the system. These extra features will allow the system to directly alert the user of any abnormal changes in the greenhouse environment through the transmission of a simple short text message, especially if the user didn't have an internet connection to receive information from the system. Reflection. Overall, the project worked as expected and the goals were achieved as initially planned. Automated greenhouse monitoring system was constructed with various necessary sensors. These sensors sense various parameters and then send them to the Arduino microcontroller, and necessary action is taken by the Arduino to compare values with preset values. AGMS eliminates risk of greenhouse not being maintained at specific environmental conditions due to human error. Labor cost can also be reduced, the system is eco-friendly, and the quality of yield can be increased. This is the end of my final video. Thank you for watching my video.